Good afternoon to all. Good afternoon to Balkrishan sir. Are you there?
Yes, I am here. Good afternoon.
Okay, sir, good afternoon, sir.
Good afternoon. Good afternoon.
So I think, yeah. So nice to meet you, sir, and thank you
Thank
for
you.
joining and accepting our invitation. So in future also we can work together. We'll see what are the collaboration we can do. We'll see. So let
Sure.
me introduce you, and then we'll start.
Sure.
Uh, I think student has already joined. Many students, let them join. So, Dr. Balkrishna Bal is a distinguished researcher and academician in the field of NLP, AI, speech processing, and machine translation, and also in language technology. So, currently, he serves as a professor of computer engineering and associate dean of project and extended programs at Kathmandu University, which is in Nepal. Thanks for accepting our invitation in a short period of time. So now, sir, session is yours. You can start the session. Thank you
Thank
very
you.
much.
And thank you, Dr. Satya, for the very good introduction. And let me just start sharing my screen.
Yes, sir. I have already made you the co-host. You can share this.
Sure, yeah. So screen is visible, right?
Yes, sir. Visible, sir.
Good. Okay. All right. Very good afternoon to all the workshop participants. Today I'll be talking about low resource NLP in the era of large language models.
Balkrishan sir, can you make it full screen so that it is showing the next slide also it's showing. So can you make
Oh,
it full screen?
okay, okay. Just a second.
Yes.
Just
It
a
is
second.
showing the next slide also. You just make the full
I'll do
screen
that.
only.
I'll do that.
Yes, sir. Now it's okay. Yes,
Now
sir.
it's okay, right?
Yes, sir.
Okay. So I'll be talking about low resource NLP in the era of large language models. So challenges, techniques, and practical workflows. I try to basically make it generic, but some examples basically come from Nepal and Nepal's languages. I hope that will be fine. So basically, I work at the Information and Language Processing Research Lab and at Kathmandu University. And this lab was established in 2004. And since then, we have been working on different language technology domains like machine translation, automatic speech recognition, text to speech, OCRs, information retrieval, and so on and so forth. Right. So that was a brief introduction about the lab. Okay. So about the roadmap today, I'll be basically covering these many things. So I'll be introducing about this low resource NLP and why this is important, right? And what is really the motivation factor. And then we'll move on to understanding the low resource NLP, what it is, and then how this NLP technologies have evolved over time, starting from rule-based to currently large language models, right? And how that this has basically changed the landscape, right? And then moving on to LLMs and multilinguality, how LLMs are helping multilingualism, and then what benefits this low resource languages in the region can take from this. And then I'll be introducing some techniques for low resource NLP, and then I'd also be going through the practical workflows of how one may take up this low resource NLP. And then finally, I'll be talking about the challenges and risks, and then I'll just basically close the session with future directions. Okay. Okay, so let's look at the introduction and the motivation part. So why language basically matters in artificial intelligence, all right? So the reality is that AI is not equally accessible across languages. So there are these, high resource languages, and there are these low resource languages. There are these under resource languages. There are the zero resource languages, and so on. So what we can see here is that AI is not equally accessible across languages because we cannot really imagine AI technologies without the presence or availability of some data, right? So data is very prominent and data is very crucial. And as we can see here, the reality is that the English language dominates NLP research and resources. So it's the predominant language in which most research works have been done. And there are, however, unfortunately, thousands of languages which remain digitally underrepresented, right? So they don't have the resources, they don't have digital footprints, and some of them don't even have written traditions. They are not supported by Unicode and so on. So even for other, let's say, low resource languages, meaning those languages which have, I mean, it's not like they have zero resources. They do have some certain resources, but unfortunately, AI systems often perform poorly on these low resource languages, right? And then the sad thing about this is that this linguistic exclusion can become digital exclusion. So earlier we used to talk a lot about digital divide, and we used to say that the English language was the major culprit behind this digital divide because not everybody speaks the English, speaks or understands the English language. We used to say these things, but in the era of LLMs, in the era of AI, if these linguistics considerations or these languages are not basically included in the ecosystem, in that mainstream AI, then that would basically deprive them from being digitally included, right? So some of the key questions that we need to think about are who benefits from AI. So who are the beneficiaries and which languages are represented and how can we democratize AI, right? So we definitely there are high resource languages who have been greatly benefited by all these technologies because that they have these high resources, they have these technologies and everything. But what about these low resource languages? What about these zero resource languages? How can we basically include these languages as well, and so that they also get the benefit of these technologies. So that's the key questions that we need to think about. Okay, so let's look at the global linguistic diversity. So as you can see here, the language worldwide, there are 7,000 plus languages. And surprisingly, only about 100 languages have substantial NLP resources out of the 7,000 plus languages, right? So, and about approximately 500 languages have some digital presence. That means 6,400 plus languages are still with little or no digital presence. So and there are these the LLMs, large language models, and lately a lot of LLMs supporting multilingualism also have been developed. They have come up. But interestingly, we should note that the performance of these LLMs are not as uniform or not as great across all the languages. The performance dramatically changes or varies across languages. Okay. So, what is a low resource language by definition? So, this is an important part to cover. So, basically, by low resource language, we mean a language with limited availability of digital text corpora, right, and annotated data sets lexical resources, and language technologies and computational tools, right? And some of the examples that you can see here on the right side is Hindi. Hindi is moderately high resource, so there are a lot of works that have been done in terms of resources and applications, but still compared to English, it is still moderately high resource. Whereas the other languages like Maithili, Bhojpuri they have limited resources. Uh, And Tamang, as you can see here, is a very low resource language, and Newari of Nepal Bhasa is another very low resource. And there are different tribal languages or indigenous languages which are very minimal resources and minimal digital footprints, and they are basically very low resource. And as you can see here in the resource spectrum, the orange and the red, they denote low and ultra low status, whereas the blue and the green, they denote this moderate and high resource, like that. So, and there are, discussing about the types of resource scarcity. I mean, we can basically categorize these scarcities from different perspectives. The very first being data scarcity. We have very limited raw text, no web presence, and very small corpora that leads to the data scarcity. And then we might even have some data, but then they are not annotated or they are not labeled. So the data, data that we have might be without labels, so no labeled data sets. And then we even might not have these parts of speech or named entity recognition tags, right? So, and no parallel corpora. That basically relates to annotation scarcity. And then the third one is the tool scarcity, where we don't have any NLP toolkits, no parsers or tokenizers, no benchmarks. So, so this leads to a tool scarcity. So we don't have the required tools, right, and applications. And then the other scarcity, on the other scarcity, we might have very few resources working on that particular language. We may not have native speakers as well, and there may not be labs, right? And then there could be, a lot of isolated communities. So that basically categorizes under expertise scarcity. And then the very fifth one, that's very final one, the infrastructure scarcity, where you have limited computer, poor connectivity, and no digitization funds for this thing. So as you can see here, there are altogether, 5 different heads or categories under which, we basically low resource languages suffer from these scarcities, right? So, what are some of the challenges in low resource NLP after I have discussed the scarcity or the challenges, right? So, these challenges could be threefold. Linguistically, the languages, these low resource languages, could have very rich morphology. There could be a lot of inflections, derivations, and so on in the language, in the words. And the words could be free word order as well. So it's not a fixed word order like English, but the words could come in different orders, right? And then there could be dialectical variations as well. So we were talking about we were working on the Tamang language, and there too, we have a different dialects within the language, and that makes it difficult to develop some applications, because people from a particular region might not necessarily understand the vocabulary from the other region. So there could be dialectal variations as well. And the other problem that we are facing, and that's basically that basically applies in the South Asian context or in low resource language context, is this script diversity. So there are multiple scripts that the community basically uses. There is no consensus for the use of one particular script. So that also deals with some problems. And not all of these scripts are supported by Unicode, right? And that's another problem here, right? And then some of the languages, these languages are tonal language. It's not just the script or the written um, format would not be sufficient to capture these languages, because some certain this diacritics or certain other symbols, markers would have also basically lead to different pronunciations. So even a particular word, right, it might be written, in first glance it might seem like one word, but then depending on the tone how it is pronounced, it might lead to different words, or different words with different meanings, right? So words with different meanings. So that's also another challenge of tonal languages from the linguistic perspective. From the technical, I think I have covered this well. The problem or challenges is the small data sets, right? Small data sets or unlabeled data sets, and then domain mismatch, right? So one particular model, basically, which is trained in one particular domain, might not necessarily work with the other domains. That's a domain mismatch, and there could be poor benchmarks as well. So we might have data, we might have models, but they are not necessarily benchmarked. And we don't necessarily have pre-trained models as well. So lately, these low resource languages, we have been benefiting from these large pre-trained models. And but so in the case of certain languages, that there aren't even pre-trained models which are suitable or applicable for the system. So that's also a problem. And there are evaluation gaps as well, right? Evaluation gaps as well. And most of the time we go for quantitative evaluation with this standard performance metrics, whereas for real uses, we'd need to go for some error analysis and some qualitative evaluation as well, which seems to be lacking, because and that there's a reason behind that as well, because for the qualitative and evaluation, so we need some expertise help as well, which might not always be available, right? And then there is this societal challenge as well, right? And as I hinted earlier, I mean, there could be a language with multiple scripts, and these communities basically advocating for one script or the other, right? And then they have their own identity politics stances, right? And so on and so forth. So that also basically it's creating some challenges in terms of empowering them with the technologies. And as far as the society, I mean, societal thing is concerned, so there's a lot of language preservation issues that can be basically handled with these latest advanced AI technologies. But again, we are working, and I'll just give you an example. We're working on a project where we were trying to recognize the written text from stone inscriptions, which were very old, right? Very, I mean, so since they etched, they were from a long period. So I mean, the quality of these stones, and the inscriptions were also not very good. So that also could basically make some issues or in the final output. And then the digital inclusion, definitely, I think we can sum up that up with the availability of data sets, the support of the scripts, and so on and so forth, and then fairness and bias. So I mean, the use of this pre-trained models, which were basically developed for some high resourceful languages like English and other languages, might not basically represent basically the society, the culture, the belief, and everything from the low resource community. So naturally, these models might lend to unfair or biased models. And then the community trust is always there, right? So it's a difficult thing to and earn the trust of the community, but this is something that is very unavoidable as well, because at the end of the day, it all boils down to acceptance of the technology, whom we are building this technology for, when the community does not accept it. So there is also this community trust over there, and there is this thing to address the aspirations and concerns of these different communities, or different communities, different sub-community within the community, right? Advocating for one script or the other, and might be having certain biases as well there. And then the policy support is the one other thing that we might require from the government level, right? Because without the support from the government, we cannot really implement any systems that we might develop at the academia or the research institutions. Okay. So South Asian language landscape. So let's have a look in here. So these are, I've just noted some unique characteristics. So we have a deeply multilingual societies, meaning, I mean, there are, people speaking multiple languages within the societies. There are multiple scripts, in which these languages are written, and the orthographies, the way of writings are different. And then the other rampant thing is this widespread code mixing thing. So every in a single sentence we tend to code mix the language. For example, Telugu English, Hindi English, and so on. I mean, that the trend is that we don't necessarily speak a particular language or write in the particular language, but rather feel comfortable, mixing these different languages and the text or the spoken forms as well. And we have a shared linguistic roots across families, which is a good news, definitely, because of that we can use or reuse these different models developed for one particular language across families as well. And the other challenge is that these languages inherit and basically rich morphology, accusative and inflectional, and that's also sometimes poses challenges, right? And yeah, there's this code mixing examples on the right hand side, just Telugu English, Hindi English, Bengali English, and so on. But then when I believe what I would say is that with this, I mean, it's not just a challenge, but then we also do have opportunities, right, in terms of developing the technologies and tools, because there is a opportunity that there are a lot of cross-lingual transfers, right? That's possible within these languages, and this cross-language transfer enables NLP capabilities flow from high resource languages, that's English and Hindi, to low resource languages across the region, right? So let's move on. So sorry. So now let's that was section 1. Where I briefly gave you the overview of this low resource languages, the challenges, right, and what were low resource languages and so on. Now, in the section 2, let us give a walkthrough about the evolution of NLP technologies, right? So how these technologies evolved over time. So evolution of NLP, a visual timeline, as you can see here. So we had 1950s and 80s were dominated by rule-based NLP, right? Where the focus was on handcrafted rules and dictionaries and linguistic expertise. And moving on to 1990s, now that more data started to get generated, and then that opened doors for statistical NLP, right? N-grams, hidden Markov models, conditional random fields, maximum entropy, and then the whole approach from rule-based, suddenly now the paradigm basically shifted to data-driven, right? And then starting from 2013 to 18, there was a surge of this deep learning techniques, word to vec, right, and word embeddings, all etc. And then we had this sequence models, RNNs, LSTMs, and then sequence to sequence models, representation learning, and so on. That was basically the era of deep learning, 2013 to 18. And 2017, that was a breakthrough whereby this paper, Attention is All You Need, by Vaswani et al., that basically, made a breakthrough. I mean, because it introduced the transformer architectures, right? And which basically, which basically open doors for parallelization, because of the earlier sequence-to-sequence models or the sequential models were necessarily sequential, and then these models suffered from long-term dependencies. And but then with this paper, attention, all you need, it opened doors for parallelization as well as scaling, that led to scaling, as well as more accurate in terms, because the uh, this attention mechanism was basically a result of this particular paper and the architecture, transformer architecture, self-attention, and so on. And then moving on to 2020 and more, I mean 2020 onwards, now that led to this large language models, right? So large language model, suddenly in the market we began to hear about this, all these different large language models like GPT, Claude, Gemini, Llama, which came up with some some surprisingly pleasant, and then sometimes very incredible as well. These results and outputs, right? And then yeah, so as you can see here, so and then now basically now talking about this 2025, 26. Now we have moved to multilingual LLMs. Now it's not just LLMs, but multilingual LLMs, which basically support not just the high resource languages, but also other low resource languages, and many more languages than just resourceful languages. And in this context, this NLLB, MBERT, XLMR, MT5, these languages, these multilingual large language models have been a boon for this low resource languages, and their focus is necessarily low resource focus. And rule-based, I mean, moving back, we in the rule-based NLP era, the characteristics were that these were basically focused on handcrafted linguistic rules, dictionaries, and lexicons, expert-driven grammars, finite state automata, and pattern matching, right? And they were definitely good at something in that, it's not, and sometimes these deep learning models that we have today are not necessarily interpretable, right? It's sort of like a black box. But if we were to look into this rule-based NLP, then they were definitely explainable and interpretable, because they were rule-based. So the rules are developed by humans, right, and linguists, so they were very explainable, interpretable. And they didn't require this training data, use training data, and they were very precise for limited domains. So those were the strengths. And about the limitations, as you can see here, they were very poor in terms of scalability, right? Poor scalability in new domains. So often when you introduce a new domain, then they started to break this, right? And definitely the costs were very high, because you need to pay the linguist, you need to pay the experts, and then the resource in general seem to be very costly. And then hard to maintain and update, because you need to continuously update the rules and the grammar and everything, right? And fields and language variations, even a small variation in the language, and basically does not work. So in the low resource impact. So why I'm trying to compare these different approaches is because all of these different approaches had their own impact on the low resources, on their own impact in their own forms. So rule-based systems require deep linguistic expertise per language. Building such systems for thousands of low resource languages was practically impossible. Most were simply ignored. And then each new language, if you were to add each language, this new language, that would mean the months of expert efforts, right? So that was not very practical and not very economical. And then talking about statistical machine learning era, and these were some of the key innovations in that. So these models were basically developed, hidden n-grams language model, hidden Markov model, HMMs. HMMs were very popular until quite later. Later, especially for speech, OCRs, and so on, for similar applications. And we had sequential random field CRFs and support vector machines and feature engineering pipelines and so on. And again, definitely there was some progress with statistical machine learning era, but then it had its own sets of challenges for low resource languages, and because it required substantial label data, performance is tied directly to corpus size, meaning the larger the corpus size, the better the result, and so on. And low resource language remained disadvantaged in that respect because feature engineering, we needed to do feature engineering, and that was time consuming. We needed to extract the features ourselves manually, right? And domain mismatch was another common phenomenon where models did not generalize across languages. We need to develop models per language. Statistical progress basically favored high resource languages. So, I mean, that this low resource languages basically didn't get much benefited in that time. Now, with the deep learning revolution, so definitely this opened another era and another doors for this low resource development and so on. But one of the issues was data, because the deep learning models are still data hungry, that we are aware of. But with these word embeddings and word to vec globe and then semantic vectors, RNNs, LSTM sequence modeling with memory, sequence-to-sequence models, for example, encoder decoder for transfer generation and the attention thing. This basically had a dramatical, impact in terms of, better representation learning. And then the good thing about that was the features were now could be automatically extracted from raw text, and we need not basically bother on the feature extraction part. However, the bad news still persisted was that since these models were data hungry, and deep learning, this technology seemed to be appropriate for highly resourceful languages like English and Chinese, but which had since this model required millions of examples, a lot of examples, low resource language naturally obviously lacked the data, and hence could not benefit much from the deep learning technologies. And then this transformer revolution, attention is all you need. Vaswani et al. 2017 paper, major breakthroughs from that paper, and that was that parallelization. Now we could go for parallelized in the sense that all tokens could be processed simultaneously, dramatically faster training than RNNs. That was very fast. And then the other problem, that's the long range dependency problem, also was addressed by self-attention, which captured the relationship between distant tokens and context. And then performance improved predictability with more data and compute. So that was quite scalable. And then this was indeed the foundation for LLMs, all the emergent LLMs. These are the foundation. And BERT, GPT-5, Llama, and all these all are built on the transformer architecture. Sorry. Now, moving on. So in the section 3, so we have LLMs and multilinguality. Or there I was giving examples of certain LLMs. Now we'd go in detail those examples. So understanding large language models, the core idea basically is predict that these LLMs necessarily predict the text token based on context, right? Trained on massive text corpora spanning the web. And we have a whole lot of these large language models, which is basically GPT family from OpenAI, right? GPT 3.5, GPT-4, GPT-4o, Gemini is from Google DeepMind 1.0, 1.5, 2.0 series, and this Claude from Anthropic, Claude 3, Claude 4, and Llama, which is open weight models, class 3, which is from Meta AI. And then the good thing about these LLMs, these multilingual LLMs, is that basically they have emergent capabilities, and they have they have those expertise out there, this better performance for different natural language processing tasks like translation, summarization, question answering, code generation, reasoning, and so on, right? And So why these LLMs matter for low resource NLP and how they have basically changed the landscape? That's also important to note, right? Before LLMs, before the advent of large language models, as I also mentioned earlier, so we had to develop a specific task-specific model for every problem. So for every problem, we need to develop a task-specific model. Whereas now, and then that required large level data sets per task and separate systems for translation, near and QA. So we needed to develop separate systems for different applications, right? And that resulted in high engineering costs for languages, right? And this was basically inaccessible for most low resource languages. But with the advent of LLMs now, there are different technologies that have come up, like zero shot learning, where would not require, task specific examples examples for training as well. For the few shot, there is another very useful technique called few shot learning, where we only require only a handful of examples. And then there is this transfer learning, where we could cross-lingual do some cross-lingual knowledge sharing as well. And with the multilingual support, one model basically handles many languages. So then there's this better generalization as well, works across tasks without retraining. So with LLMs, the landscape has really changed, and there's a lot of promise that has basically come up with low resource NLP and sort of democratizing AI in the context of low resource languages. So multilingual language models. So the key concept is that the shared representations across languages and one model, many tongues. So the representations are basically the representations, meaning the features that the basically model learns, right? That's shared across languages. Definitely languages with some common script or common way of writing and common vocabulary and so on, right? And these are some of the very powerful multilingual language models that have been successfully deployed or used lately. So we have this embed model. So it covers 104 languages and useful for classification, named entity recognition, and natural language understanding tasks. XLMR, that's another one, which covers 100 languages and the stronger cross-lingual and natural language understanding task. There is this Indic BART, which covers 12 Indic languages and is specialized for South Asian NLP. And we have this NLLB 200, right? So languages covered is 200 languages. It's by Meta AI, and then it has a machine translation focus. And we have been also successfully basically used or deployed this particular model in our lab as well for the trilingual machine translation system. And then we have MBART 50, which covers 50 languages and is specialized for translation and text generation. And we have M2M 100, that covers like 100 languages, and that's for many to many MT. Right. So as you can see here, these multilingual language models, they have necessarily been a boon for low resource practitioners like us. And then let's now look and now move to section 4, where we'll be looking for techniques for low resource NLP. And this is essentially the flow, right? Cross-lingual transfer learning. So how transfer works, or how knowledge transfer works, is we would have this English slash high resource data, and that is basically trained to multilingual pre-trained model, embedded XMMR, NLP 200, and so on, with the English slash high resource data, and that is basically fine-tuned on the low resource task, any low resource target language. So that's how this learning transfers from resource rich to resource poor languages, right? And the reason why it works is that it shares multilingual embedding space. Languages represent overlapping vector spaces. There are languages with orthographic similarity. For example, Indic languages with shared scripts transfers well. right? That's it's for the 2021 paper of Kim Chandan et al. And then there is this subword tokenization, basically byte peer encoding, and that captures morphological overlaps across languages. So BP, that's the tokenization. It's popularly being used for this type of tags. And then there is this massive pre-training signal. That's a digital representative built from 100 plus languages simultaneously, and that is very beneficial for this low resource languages. And zero shot, a few shot earlier we talked about this. So I think I wouldn't repeat it, but for just to give you a quick overview. So for the zero shot thing, we wouldn't require any specific training examples, right? But the model could use just the instruction prompts. And so this is ideal for extremely low resource scenarios. And we could just say, example, translate to this target language. For example, the text, the weather is nice, right? So it could be very fastest to deploy, but definitely it will have the disadvantage of having a lower accuracy, right? But I believe we can basically take it as a bootstrapping thing, So few shot learning and pull up level example 3 to 10 in the prompt and dramatically improves tracks accuracy, enables in context adaptation without fine tuning. Example 5, we can provide 5 translation pairs and then ask for the 6th. Right. So then this sort of few shot learning and zero shot learning would also very, very helpful for our case. Prompt engineering, that's another very important part, which is basically part of this LLMs, right? So prompt equals to programming. This is essentially equivalent to programming language for large language models, and it's very important to design good prompts because on that basis, your output will largely depend on, right? So if you have a bad prompt, if you're not so good prompt, then your outputs would be, accordingly in that particular quality. So I mean, there are just examples of what would be a good prompt and what would be a more effective prompt. For example, as you can see in translate Biralo, that's a cat in Nepali, that's a Biralo, right? And if you just give such a prompt, that would be very weak prompt, very bad prompt. Whereas a more effective prompt would be translate the following word from this source, Nepali to English, for example, and input would be Biralo. And if you just provide output, so that would be a very effective prompt, right? And that's for the translation tags. For the classification, similarly, we can as you can see examples. We can do such. We can provide such a prompt for summarization and the same things. Okay. Synthetic data generation. So low resource languages suffer from adequate data, and one of the techniques is definitely data augmentation, and synthetic data generation is one of the ways to basically augment the data, right? And one of the ways could be of generating synthetic data in the context of, let's say, machine translation could be back translation, right? So in that case, you basically translate the language into English, and then from the English to you back to the language, creating some bilingual pairs automatically. And we basically did that for NEPTAM, this ATK, which was synthetically developed, which were synthetic corpus, parallel corpus, based on the output of the 20K manually developed corpus, which were fed to the NLP model, right? So that's that way we developed ATK pairs, and then we tried to improve the output of the model using both the manually annotated data as well as the synthetic data, right? And the back translation, and then other could be LLM generated data as well. Quite a many times we take the help of LLM, and there is this concept called LLM as a JAWS as well. So where we basically could take the help of LLMs to generate certain labels, and then ask another LLM to basically verify whether the generated labels are correct or not. So that's also one technique So LLM generated data prompt GPT Claude to generate labeled examples for net, sentiment, QA, and low resource language. So that's another useful way of doing this thing. Definitely, we need to verify the generated output, but this is quite a efficient way to do that because doing that manually would take a lot of time and effort. So data augmentation, so word substitution, paraphrasing, noise injection, multiply existing example without new annotations. So this is also one of the things that you could do. And we could also go for template-based generation. So we fill structured templates with vocabulary, and which is useful for morphological rich languages. And the benefits of this synthetic data generation from different methods would be rapid dataset expansion. Enables training when human annotation is scarce, scalable with LLMs. And then another important part aspect of the method, the technique for low resource language would be retrieval augmented generation (RAG). Right, the big issue with these LLMs is this problem of hallucination. Right, so hallucination meaning this LLM generate this plausible sounding but factually incorrect text. And they basically generate and they provide with such a confidence that sometimes we fall prey. We take it seriously, and then we basically are encounter with a problem, right? And if we go by this hallucinated output or incorrect text or output, especially in sensitive domains like healthcare, legal, and government context, then we might run into problems, right? And hence, in order to correct that thing, this hallucination problem, so the solution is going for some external retrieval, right? So we retrieve verified documents at inference time and inject them into the prompt, thus grounding the model's response in real knowledge. So there is the RAG workflow. So we have the user query, and then we have the document retrieval from different sources, and based on that, our prompt is augmented, and our prompt is basically enhanced, and then that is fed to the LLM, which basically generates some grounded response, right? So retrieval augmented generation could be basically a very useful exercise, or something that's a go-to exercise for low resource languages. Now let's look into the practical workflows. So for what we essentially do for low resource languages. So here are these 7 different blocks, as you can see here. And the very first one would be problem definition. So we need to define the task, what we want to do, right? The language and the domain scope and so on. That's the problem definition part. And then the second block layer, not the block, let's say layer, would be the data collection thing, right? Where we scrape the data from the web or corpora or the community resources. And not all the data that we basically collect from these sources are clean, and it could be used right away. So we need some data cleaning thing. For that, we need to go for data deduplication, so whereby we basically remove the duplicates, and then we need to normalize this data. We need to do some semantic filtering as well. So for example, in the project, in the trilingual machine translation project that we worked at the lab, we tried to we attempted to include syntactically diverse and semantically diverse text as part of the source corpora. We basically started with Nepali as a source, or the pivot language, or a link language, and then we translated that source to Tamang and English. And in that case as well, so we had to apply different, some different mechanisms so that we could include diverse, syntactically diverse thing of different tenses, and then semantically different meaning with negations, without negations, and so on and so forth. that's something, some filtering thing that we generally during the data cleaning process. And as I was talking earlier as well, I mean, sometimes in this in case of, in case of very, very poor or low resource languages, we need to take the help of LLMs, and we need to go for developing some prompts, right? Designing some prompts via the zero or slash few certain techniques where we provide prompts, instructs, and tuning, right? And that way we basically improve the prompts, and then try to extract better information or better knowledge from the LLMs. And then the other important part would be model selection. Definitely, low resource languages, we need to go for those large language models with multilingual support, right? So for that thing, as I mentioned in the previous slides, so Embert and LLP, GPT or Llama family, these are very popular, and we could basically choose one of these based on their performance and their suitability or appropriateness. Definitely, any model that we would have fine-tuned or trained from scratch needs to be evaluated, because at the end of the day, we need to evaluate how good these models are and what are their outputs, right? How their outputs are. So for that, we need to go for certain evaluation metrics. Blue was popularly used in the early days, mostly for machine translation, right, and other applications which assess the minimum edit distance, like thing between what was generated and what was supposed to be generated, the differences, right? But lately, the CHRF is getting more popular, in the sense that it would not just look into the words, but the individual characters, right? And BOT score is mostly popular for semantics, how the output. Those models with better semantic outputs. BOT score is very common, very popular. And earlier I was talking about qualitative evaluation, and that's human evaluation, and definitely the error analysis part, besides the quantitative evaluation, is also very important. And I would say that for the low resource things, since not everything might be captured by these models, even they are multilingual, even if I fine tune them, then they might not basically reflect our culture, our societal beliefs, and so on. And so to make sure that something good is coming out of these models, you know um, we need to have some human evaluation conducted, a qualitative evaluation conducted on the output of this model, so that this could be some of the lapses could be corrected on time. And then for the deployment thing, definitely we could deploy via APIs, by releasing the APIs, right, and local inference monitoring iteration. Definitely, deployment has its own pains, and we are also facing the problem right now, in that because we don't have the GPU machines required, for mass deployment. I mean, for the deployment is not an issue here. We can deploy it, but what about if there is a lot of queries at the same time from a large number of users? We don't have the machines, so we don't have the computer infrastructure to support that, and so deployment is sometimes quite tricky. So in that case as well, so it's not just important to develop the models, but also to come up with a way how it could be effectively deployed to the community. So in that respect, there could be, I mean, a situation whereby academia, government, the community, and everybody else, the industry, need to join hands to basically so that the R&D of the product that we might have developed basically gets deployed effectively. A few applications for low resource languages and the use cases, right? So machine translation, so where it could be used. So one of the areas could be this government documents and legal text translation, right? And education materials and textbooks, tourism, hospitality content, cross-border communication, healthcare information leaflets. So these are some of the use cases where machine translation could be very useful. And then there is this multilingual opportunity as well in the context of low resource languages, in that this empty systems like NLLB to 100 supports 200 languages, and fine tuning on only a small parallel corpora would yield strong results, right? And for example, in case of Nepali Tamang, even with the 20K parallel corpus, we are able to achieve blue above 40. So I mean, so this is just one corroborative proof, for example, that it's not like low resource languages would require a lot of resources, but if we basically develop some quality resources and then take the help of these multilingual models, then we can achieve some decent results and output. So in the ILPRL work, so basically with this machine translation, trilingual machine translation that I was talking about earlier. So we had this 100,000 parallels. I'm telling you, 100,000 source sentences in the Nepali language is scrapped from the web. And then it's not like we scrapped randomly all the 100,000 sentences and then directly jump to translation, but we made sure that these 100K source sentences were syntactically and semantically diverse, and at the same time, this came from 5 different domains. And these education, health, then the culture, tourism, then general communication, and so on, right? So there are these 5 different domains, so that we have a good mix of these source sentences. And then the other application could be this conversational AI, which could basically be used in the form of citizen services, education assistance, and healthcare information, right? And we can basically develop some government chatbots which responds to in local and regional languages, making services accessible to all citizens. That would be very useful. And then for educational assistance, we could have AI tutors that explain concepts in mother tongue languages, supporting first generation learners. Even with this trilingual machine translation system, so one of the motivations was that um, the Tamang speakers could highly benefit from the knowledge that would be available in Nepali or English languages in the internet. So internet is predominantly English. So a lot of knowledge could be basically translated to Tamang. And accordingly, from a lot of knowledge from the Nepali could also be translated to the Tamang language. And for the healthcare information as well, definitely this conversational AI could help in basically getting some preliminary information about the health status and some queries or some concerns that the common people might have. Right, they could just check with the symptoms and the illness, and then get necessarily some advice. So yeah. So key design principles is conversational AI must be designed with cultural sensitivity. That's very important. Language fidelity and awareness of local context, not just translated from English. So since both machine translation and conversational AI, the direct stakeholders will be the community. So it's very important that the community is involved right from inception, right from the design of the project. To the different linguistic resource development, as well as the feedback to the development process of these different systems. Third application would be cultural heritage preservation. So NLP and AI would be one of the very useful in terms of preserving the cultural heritage. So NLP, for example, could be used for preserving these historical archives and manuscripts, which would otherwise be destroyed over time, right? There could be, we could also transcribe and translate this oral history, right? NLP could also be used for documenting language documentation for endangered and indigenous languages. Sorry. Okay. Can you see my screen? Okay. Back to my screen then. Okay. All right. Yeah. So I was talking about yeah, about documenting this endangered and indigenous languages, right, through NLP and digitization of this classical literature and community memory preservation and so on. So digitization initiatives, as far as the design initiatives is concerned, we could look into this endangered scripts, right? There are these minority and classical scripts which could be digitized for religious and cultural texts, and we have these classical manuscripts as well, which could be preserved, right, through OCR and NLP, which is an active ILPRL focus. And the oral traditions, right? There's a lot of speech in there in different communities, and that could be basically, transcribed before they are lost via this speech technologies or ASRs. And I basically also include here one particular quote: "Every language lost is a library burned." So that would be very unfortunate if we lose a language. It's equivalent to a library being burned. Now, finally, the challenges, risks, and future. So I come to the almost the last part of my talk today. Um, so evaluation challenge. Sorry. Yeah. So what are some of the challenges here? So earlier I was talking about all of these different matrices that are quite popular, right? And we have this blue, Rose, CSRF, CSRF plus plus, BART score, and Comet, and so on. But alongside with these different matrices, I would highly suggest that we also go for human evaluation, because this is very indispensable, right? Especially for lower source languages, where automatic metrics may not capture the cultural nuance, idiomatic uses, and syntactic accuracy, pragmatic appropriateness. So we need to plan for a human evaluation even when the compute is scarce. Yeah. Risks and limitations. Definitely, there are these LLMs comes with certain risks. There could be hallucination. Hallucination risks. There could be bias risks. There could be cultural misrepresentation, and then the data privacy issues, right, and resource concentration. So all of these things are there, right? But still, I mean, there are risks and limitations, but we need to make use of these LLMs. I mean, wisely and very, so that we take the best benefit out of them. Okay, so some future directions. So. One of the issues would be this compute infrastructure and compute support and everything. So we might need to go for some small language models development, which would be more efficient and locally deployable models, fine-tuned for a specific low resource language without massive compute. So we need not go for large language models. So we could go for some small language models. And we could concentrate on some domain-specific large language models, legal, medical, agricultural LLMs built on specialized corpora for high stakes, low resource applications. And then the world is going increasingly multimodal, so we could also go for multimodal AI, speech plus text plus image models, serving oral tradition communities and users with low literacy. So we would need to go for speech language models, in that we need to, go for end-to-end ASR plus MT pipelines for spoken low resource languages and oral traditional communities. In fact, for the trilingual machine translation as well, we are planning in that direction. So we now have a machine translation system, trilingual machine translation system ready for, at least Nepali, English, and Tamil. So we could add on just the infrastructure is ready. So we could just add other languages, and together with that, we could also, the plugin or develop this end-to-end ASR and TTS technologies in this system, this trilingual machine translation system pipeline, so that we could have input in the speech, and the translation is done in the background, and then we would have output. That's the translation also read out in the speech form. So that's something that we could benefit. These large low resource languages could benefit from that. Definitely now, the other thing would be indigenous language AIs, because these indigenous languages would not have the technical readiness as well. So we need to develop some standard technology for these indigenous languages as well. So that would require community-driven development with native speaker involvement. Major thing is we need to assure, that we are developing these technologies for their benefit and their welfare. They need to own the system, right? And then data sovereignty is another important part. So for our comfort or simplicity, we might prefer to use the cloud-based, infrastructure, but as far as data sovereignty or AI, sovereign AI is concerned, so it might make sense to basically develop our own systems and own models, so that we host it somewhere in our custody. So that's also something to think about. Some regional and institutional perspective, there are several opportunities here, right? Government services in local languages. So the one just information for non-Nepali audience here, that the Nepal government has recommended a few working languages in different provinces of the country besides Nepali, which is the national language, right? Or the official language. These other working languages also are considered to be the national and the official languages. So there is then opportunity to basically extend the use of these MT systems across government services, right, in different provinces. And education sector localization, that's another area where we could basically work on digital archiving of endangered languages, AI startup ecosystem, international research collaboration, and so on. But still, this field would require, quality data infrastructure. So we need to build the infrastructure, research talent and funding. That's a very crucial issue. And then we need to have a supportive government policy at hand. Here are some of the ongoing works at ILPRLKU. So this NEPTAM MT, we already published as part of LREC 2026. So we have released 20K parallel data and 80K synthetic data there. And then we are also working on Nepali ASR, Nepali named entity recognition and parts of speech, right? And Nepali MT for the legal domain. That's also something. And another one area is Nepali NLU, natural language understanding. We're also working on this. So concluding remarks. So that's my last slide here and of the talk. So LLMs have transformed the landscape of low resource NLP, that's for sure. And data scarcity remains the most critical bottleneck. Corpus building still matters, right? Transport learning and multilingual models offer unprecedented new opportunities, which we saw in the slides. And responsible inclusive AI development is both a moral and technical imperative here. And the future of AI must be multilingual and no language left behind in a true sense. Thank you so much.
Thank you, sir. Any questions from the audience side? Sir has given a path how to start. Okay, what are the different steps are there? What are the different challenges are there? What he is doing currently? What are the current projects are going on? Okay, and sir has also given his mail ID. If anyone wants to contact him
Yeah,
to
sure.
start some work, you can also. If you have questions, you just unmute yourself. Then you can ask. Yes, now you can unmute and you can ask if any questions are there. So lots of students also are joined from your institute also. I came to know.
Oh, I heard that. Yeah.
So, is any questions,
Sir,
Annapurna? Anyone?
excuse me, sir. I have a question.
Yes, please.
Yeah, Aditya.
Good afternoon, sir. I am
Good
from
afternoon.
KU itself.
Okay.
It was a very insightful talk, sir. Firstly, I would like to, many congratulations on DPI AI Lab collaboration with Digital India Vasini. And my question to you is, in this current era, in this AI NLP era, what are your future plans for strengthening the Nepali NLP community through the lab itself? And how do you see the future of Nepali NLP?
Thank you. Thank you for this very important question. So, as I mentioned, the landscape of AI and NLP is gradually, changing day by day, right? I mean, if earlier we used to, I mean, even the teaching learning used to be, based on a particular textbook, particular, slides from certain authors and so on. But now, basically, the classical NLP thing is, I wouldn't say it is fully replaced, but it's gradually replaced by LLMs, and then there is the multilingual LLMs and so on. So I believe that there should be some collaborative efforts from the academia, from the government and the community, because one agent or one particular entity cannot really work to the best, making the benefits there. So and then what I think is, first of all, we need to work on developing some quality data sets and then making these the data sets public. The second thing is also making these and these models and the recipes public and open source, so that they could be replicated and taken benefits by the wider community. The third thing is about the compute thing, because that's a real problem for our students and the academia as well. And there is something that we need to collectively work on. How do we basically manage this compute infrastructure, right? And it's not possible via just one effort of one institution or one lab. And then this is where the government and industry and the academia need to work in general. So, and it's not like in the past that somebody does a research or something in an isolated manner in just one small lab inside a small institution. Now everything is getting global. So whatever you develop, the globally people are getting benefited. So in that respect, we need to widen our perspectives and make it in such a way that the research gets sustainable, and then the efforts also basically is in general beneficial to the larger community. Thank you.
Yes, sir.
Thank
Good
you, sir.
points. 3-4 points are there. You have already mentioned that qualitative data, that corpus is required definitely, and computing. These are the 1, 2 things they are very much required, and whatever things you are doing, that is make it globally, means it is recognized globally, and all will be benefited. If somebody
Yes.
means from our country also, somebody works on the Nepali from my states also, so definitely data set requires data set, qualitative data set, and computing also. So anyway, and thank you very much. Very soon I will contact you regarding
Sure.
some collaborative work. And
Oh,
thank you very much. If no questions are there, and then we can end the session here. And the session was very informative, sir. Thank you very much once again.
Thank you.
yellow